Welcome to The Explainer. So if you've been anywhere near the internet, the news, or, literally any business meeting lately, you've probably been completely hammered by the same three words: AI, machine learning, deep learning. People just throw these terms around constantly, right? Like they're all exactly the same thing. And it's so easy to get massive buzzword fatigue when a tech trend is hyped up this much. But honestly, most of us still don't really grasp what's actually going on under the hood. Which brings us to the absolute most important question we can ask today. What does machine learning actually mean? Now, if you're feeling a little lost in all the terminology, you are absolutely not alone. It can feel like navigating a total maze of jargon. But today, we're going to completely untangle the whole shebang. We're stripping away the fancy vocab, ditching the sci-fi movie cliches, and looking at exactly what this technology is, how it actually functions, and, most importantly, why it matters to you. Okay, let's dive into this with a clear roadmap of how we're going to untangle this massive topic step by step. We'll start with Section 1, Beyond the Buzzwords. Then Section 2, How Machine Learning Works. Section 3, 3 Ways Machines Learn. Section 4, The Training Data Problem. And finally, Section 5, Societal Impact and Privacy.
All right, starting off with Section 1, Beyond the Buzzwords, the core shift.
To really get what's happening right now, we kind of have to look backward for a second. For decades, traditional computer programs ran on rigid, fixed instructions. Basically, a programmer sits down and types out manual rules. Hey, if X happens, then absolutely do Y. Everything follows that incredibly strict human-written logic. But machine learning? It totally flips the script. Instead of hard-coding every single manual rule, we just feed the system data. I mean, oceans of data. And from all that data, the system figures out the patterns completely by itself. That's the real game changer here. Learning from examples instead of just blindly following a list of explicit rules.
Moving right along to Section 2, How Machine Learning Works, Pattern Recognition.
Now, what's really interesting about this slide is how it grounds this abstract idea in something we literally deal with every single day, our email inboxes. Think about your spam filter. Back in the day, human developers literally had to sit there and define the rules. They'd write code saying, if an email says free money, block it immediately. But today, machine learning systems crunch through millions of emails to recognize those sketchy patterns automatically. The system just naturally gets better at spotting spam over time, and it's not because a human programmed every rule. It's because the AI learned straight from the data itself. And that brings us to a massive reality check. As our source material points out, it is absolutely crucial to remember that this isn't magic. It's not some super sentient sci-fi brain glowing in a server room somewhere. It is simply pattern recognition at scale. The system is just relentlessly, and I mean relentlessly, hunting for relationships hidden deep inside vast oceans of data. Humans just can't manually analyze billions of data points fast enough, right? So the machines step in, and this massive scale pattern recognition powers almost every major industry right now. Take streaming platforms. They learn the exact pattern of what you watch to recommend what to binge next. Banks? They scan millions of transactions to spot the shared characteristics of fraud. Hospitals feed in medical scans so the algorithm can recognize tiny abnormalities. Retailers use it to predict your shopping behavior based on your past purchases. When you really break it down, it's literally all just patterns. But hold on. Here is an absolutely crucial distinction we have to make. People constantly assume these systems understand things the way you or I do, but they don't. No way. They just recognize statistical relationships. For example, a machine learning model could be amazingly good at picking out cats in a massive batch of photos, but it doesn't actually understand what a cat emotionally means. It doesn't know what a cat feels like to pet, or actually, scratch that. It doesn't even know that a cat is a living, breathing animal. It simply recognizes a statistical arrangement of pixels that we label as cat.
Okay, let's get into the mechanics. Section 3, 3 Ways Machines Learn.
The first method, and this one is super common, is called supervised learning. Basically, think of this as learning with the strict answer key that humans hand over. The AI is fed labeled examples. We explicitly tell the machine, hey, this image right here, that's a dog. Or this specific transaction, yeah, that's fraud. The AI studies these highly structured examples and then gradually learns how to classify new similar data all on its own. Then we have the second method, unsupervised learning. Now, this is where we take the training wheels completely off. The AI gets hit with massive amounts of totally unlabeled data and essentially plays detective. Or maybe like a highly caffeinated data sleuth. It tries to spot hidden patterns, strange behaviors, or complex groupings entirely on its own. This is an absolute game changer for things like customer segmentation, discovering new behavioral trends, or sifting through massive analytics where humans honestly don't even know what patterns they're supposed to be looking for yet.
The third method is reinforcement learning, and this brilliantly illustrates how we actually teach complex, autonomous robots. Honestly, just think about how you train a puppy. The AI learns through a system of rewards and penalties based on its environment. Good actions get a reward, bad actions get a penalty. Over time, through just massive amounts of trial and error and experience, the system figures out the best way to behave. That's the exact tech powering modern robotics, advanced AI agents, and self-driving cars.
Which brings us to the catch. Let's look at Section 4, the training data problem.
So up to this point, this all sounds pretty amazing, right? But there is a massive, massive complication. These systems are not inherently neutral, perfectly objective judges just because they're made of computer code. They learn from human-created data. And, well, let's be honest, human history and human data are packed with bias, errors, historical inequalities, and some deeply flawed behaviors. If the training data we feed the machine is flawed, the AI itself inevitably becomes flawed. It's the oldest rule in tech: garbage in, garbage out.
So the crucial point is that this isn't just some abstract philosophical debate you'd have in a dorm room. This has dangerous, very real-world consequences. If an AI used for hiring is trained on biased historical data, it's going to learn to automatically screen out certain candidates, executing discriminatory patterns. If facial recognition systems are mostly trained on a narrow demographic, you're going to see severe accuracy problems for everyone else. And if the training data is just full of junk misinformation, the AI is going to confidently repeat that junk right back to us as if it's absolute truth.
Let's zoom out to the big picture now. Section 5, Societal Impact and Privacy.
We really need to step back here, because this technology touches literally every aspect of our lives today. Machine learning is shaping the modern world way more than most people even realize. When you take the incredible pattern recognition of machine learning and you combine it with the massive mountains of behavioral data collected on us every single day, well, AI becomes this terrifyingly powerful prediction engine. It dictates the ads you see, the content on your social feeds, sometimes even the financial opportunities you get. It predicts your purchases, your attention span, your emotional triggers. And because it is so good at predicting us, it opens up these huge, alarming vulnerabilities around privacy, manipulation, mass surveillance, and cybersecurity.
So machine learning is no longer just an IT issue. It's a societal issue, a psychological issue, a cybersecurity issue, and we are really only just scratching the surface of how deeply it's going to shape our future. Drawing from our source material today, Maya from Privacy Club leaves her audience with a really powerful thought, and I want to leave it with you on this final slide. If AI is this capable of learning your deepest patterns and predicting your behavior, who actually controls your digital autonomy? Something to think about. Thanks so much for joining me on this explainer. Keep asking the hard questions, and I'll catch you next time.